Here is another sealed microecosystem based on the procedure I showed in an earlier video. As before, I used a culture of pond algae and microbes with a trace of goldfish food. However, for this slide, I added a few microliters of molten 0.5% agar and mixed with the pipette to give 0.1% total, then sealed with a Vaseline-treated slip. This should form a very thin gel intended to restrict motion of microbes. A low magnification overview at normal speed shows a stentor in the center becoming more noticeable at 25x speed, and a cephalodella and a bit of debris at the upper right. At 500x speed, amoeba motion is clearly visible. Usually it's hard to get a haltotyr to stay in frame at high magnification long enough to get a good look, but the gel is holding this one in place well enough to see some detail. Note that these higher magnification clips are in 3D with red-blue glasses. Here is an Amphileptus also finding unfamiliar viscosity. Here is a Paramecium bursaria at normal speed. Then at 25x normal. Now a regular Paramecium. And the cephalodella now escaped from the original debris. I really enjoy cephalodellas. Given time, they create a tube from local material and travel back and forth, presumably consuming bacteria that grows along the edges. Here, the agar gel provides a transparent substrate that the cephalodella tunnels through. Here is a low magnification view at 3 days after preparation. At normal speed and 25x normal, you can see the cephalodella moving up and down its tube, as well as a nearby gastrotrich. Speeding it up further, you can see a bubble forming from oxygen generated by the algae. Note the dark rock a little above the center. This will help orient you when the field of view shifts in the next few sequences. On day 4, back to 100x normal speed, note the Paramecium dividing, just left of center. I switched to infrared illumination to try to stop the bubble growth. This usually results in the bubble shrinking, but the agar gel may be affecting the process. The cephalodella continues along its path. Day 5, using a lower light level to minimize bubble growth, shows the cephalodella still going, and a rotifer and a few Paramecium bursaria near the bubble. Day 9 shows a lacrimaria and a nematode near the rock, with the cephalodella extending its path. Later on this day, the cephalodella lays an egg. Day 11, the bubble is interfering with the cephalodella path, but you can see the egg to the right of the rock, shown in the blue box. A close-up shows the egg in its final stages, eventually hatching to a new cephalodella. A few Paramecium bursaria and gastrotrich share the experience. Day 15 shows a cephalodella at a different location, along with an egg and a number of Paramecium bursaria. Day 18 at the same location now shows 2 cephalodellas sharing the path. Leaving cephalodellas for a while, on day 26 I got this cool sequence of a naked amoeba trying to capture a Paramecium bursaria. I didn't get an actual capture, but did find an amoeba apparently in the process of digesting one. Day 30, the ecosystem is still going strong. Back to cephalodellas, this one deposits an egg while under infrared illumination. Most of the previously seen microbes are still there. Dark field illumination gives a better view of the Paramecium bursaria. Since I was going to be out of town for a few weeks, I set the time lapse at 5-minute intervals, hoping there would be no interruptions from power failure or operating system updates. Squeezing the files another fourfold gives 60,000x speed. The gel matrix appears to decay over this time, with algae strands moving around, probably from activity of Paramecium bursaria and amoebas. Now, some 2 months after preparation of this microecosystem, most of the microbe species have disappeared. I think the most interesting activity remaining is the amoebas trying to catch the Paramecium bursaria. Thank you for watching. Questions, comments, and suggestions are welcome.